Today we are going to discuss about the chapter number 5, Surface Chemistry, part 3. Topics we are going to take up is preparation of salts, purification of salts. Salts means colloidal solution. So let us start with a very good thought. Loyalty and respect goes both ways. If they don't return it, they don't deserve it. Means if we give respect, then people will give you respect. If you are loyal to any organization, the organization will be loyal to you. So loyalty and respect goes both ways. So learning outcomes from this session is preparation of colloidal salts. You will be able to tell there are two methods, dispersion and condensation, and purification. We are having three methods, dialysis, ultrafiltration and ultracentrifugation. So let us discuss in detail. So as we have discussed in the part 2 video, types of colloidal solution, we are having two types of colloidal solution, lyophilic and phobic. Philic is water loving. Water loving means it is stable and are not easily get precipitated, and moreover they can easily obtain by mixing dispersed phase and dispersion medium. But in the case of lyophobic salt, it is not easy to prepare. They are not stable as such. They are irreversible in nature. Their surface tension is nearly same. So for that reason, we are more concerned about the preparation of lyophobic salt than lyophilic salt. Lyophilic salt very easily it can prepare. And once it is prepared, it won't be having quite stability. So therefore, we need not to bother about lyophilic salt. We are now having more concentration on lyophobic salts, how to prepare that. Okay. So now the preparation of lyophobic salts are divided into two categories, dispersion and condensation. In this, dispersion is also known as disintegration. Disintegration means breaking of large particle to small particle. Condensation means small particles we are aggregating. We are joining together the small particles to form big particles. But ultimately, whenever I am talking of particle, the colloidal range, the colloidal size of particle will prevail. That is, as I earlier also told, 1 nanometer to 1000 nanometer. In some books, it's 1 nanometer to 100 nanometer also given. Okay. Preparation of colloidal salts or solutions. Methods are dispersion or disintegration method. Under that category, we are having mechanical, means disintegration or breaking through mechanical means by the use of colloidal mill, and electrode disintegration or disintegration through electric means by passing electricity, by passing electric arc. Third is under this dispersion, mechanical disintegration and electrode disintegration, and then peptization. Peptization is the precipitate we are dissolving in some dispersion medium of an electrolyte. We are going to discuss in detail. Second type category methods are condensation or aggregation method. Under that, basically 4 methods are there under chemical reaction. So what is that? Double decomposition, reduction, oxidation and hydrolysis. We will discuss each one in detail. Exchange of solvent, condensing vapors of substance into the solvent and excessive cooling. So these are the methods for the preparation of colloidal salts. So now discuss first method, mechanical. With mechanical means dispersion through mechanical means. Mechanical force. It is like a mill like wheat flour we are making. How we are making wheat? We are adding and flour is produced. The same manner we are adding the large size colloidal particles and through this hopper, and this mill will break that particles into the size which is required by us, that is colloidal size. Okay, so this is stator and all that. So as such construction is not required. We need to know that colloidal mill, what is the purpose? Purpose to break the large size particle into colloidal size particle. That's all. Okay, so now the next method is electrical dispersion. So first and foremost thing, you need to understand that it is also a disintegration technique. It is also breaking of large particle into smaller particle. It is specifically used for metals like gold, silver and platinum. And gold is, if the name is here written, purple of Cassius. So it means it is a gold salt. Gold, silver, platinum salts are very difficult to prepare. So we are using electro dispersion method. So here you see there is a their bathtub, and here water is their solvent, and with the KOHS alkaline medium, and what we are doing is we are providing the arc, electric arc, and whatever the solution we want to prepare. For example, I want to make gold soap, so metal will be taken for gold. Gold metal is taken, electricity is passed through, electric arc is passed through, and once the electric arc is passed, you see the what is the dispersion medium here, and outside it is a ice cold solution. Ice cold solution or ice is kept to decrease the temperature. Now very high temperature is obtained when you pass the electricity, and this solid will immediately change, is converted into vapors. And once it is converted to vapors, the outside cooling atmosphere or the low temperature will condense that vapors to form the solution of gold, and the gold solution is also known as purple of Cassius. So similar way, silver and platinum also are obtained through Bredig arc method. This is the electrical disintegration method or dispersion method. Next method is peptization. Peptization, what we are doing is we are taking precipitate and we are changing into colloidal solution by shaking with dispersion medium in the presence of small amount of electrolyte. Now you should understand that why precipitates are formed. Precipitates are formed due to charge neutralization or charge separation. Whenever you are adding electrolyte, what is happening is again the solution are getting charge particles. So once the charge particles are available in the solution, that will remain as a solution, not precipitate. If a charge in any way you are removing the charge, that will cause the precipitation or coagulation. Okay, so opposite thing we are doing. We are introducing the charge by adding the electrolyte. For example, when a freshly prepared precipitate of silver iodide, we are taking silver iodide precipitate and adding a dilute solution of silver nitrate. Now you see, when you are adding silver nitrate, Ag plus and NO3 minus, these ions you have added. So solution is charged now. So the one solution is charged, the precipitate will no more be available. Now solution will be added. So this is the method for preparation of solution, colloidal solution by the peptization method. Okay. So now next thing is now we have discussed the first category, dispersion or disintegration method. Under that, mechanical disintegration we have discussed, where we have discussed the colloidal mill. Electro disintegration we have discussed, where we have discussed Bredig arc method, which is used for mostly for metal like platinum, silver, gold. And then peptization we have discussed, we have adding the electrolyte and converting the precipitate into the solution. Now the next method type is condensation. Condensation aggregation. Here the point is the particles are smaller in size and we are combining together or aggregating together the small size particles to a colloidal size particle, that is 1 nanometer, 1000 nanometer. Next is chemical reaction method, double decomposition. You know that reaction of type. You will see the reaction and you will understand more. Reduction, oxidation, hydrolysis. These are the four type of reaction coming under chemical reaction method. And then exchange of solvent. Solvent means solvent we are going to change. For example, earlier it is prepared in alcohol water. Now we are changing into earlier, for example, it is alcohol dispersion medium, and now we are changing to water. So this way the exchange of solvent and condensing vapor of a substance into the solvent. So excessive cooling also, these are the methods. Let us discuss in detail. So here, as I told you, the four methods are there for chemical. Let us see double decomposition. So reaction you know already, A, B, C, D, A, C, B, D, like the displacement of ions is there. Now you see here, what is happening? Oxygen is exchanging with sulfur. So sulfur is coming here and oxygen is going here. Now what is happening? The ions are displaced. Double displacement. Oxygen is displaced with sulfur and sulfur is displaced with oxygen. So this way AS2S3 and water is formed. Now this method, a colloidal solution of arsenic sulfide is obtained by passing a hydrogen sulfide into a solution of arsenic oxide. Means to prepare the arsenic sulfide solution, we are passing H2S gas through arsenic oxide to get this solution. This is double decomposition method or double displacement method also we are using the word. Oxidation. Oxidation, you know that addition of oxygen or removal of hydrogen is called oxidation. And you see here sulfur dioxide is changed to sulfur. It means loss of oxygen is happening. It means sulfur dioxide is reduced to sulfur. And if you are talking of H2S, sulfur is gone out and oxygen is added. It means H2S is oxidized to water. So means to say that H2S is oxidized to water, sulfur dioxide is reduced to sulfur. This is the oxidation reduction reaction. Here we can get the solution of sulfur by passing the H2S gas into a solution of SO2. So this is the method of preparation of sulfur sol and through a oxidizing agent. Now if you see what is the oxidizing agent here, first reaction, if you want to see what is the oxidizing agent, then you can very well say that because H2S is converted to sulfur, this is the point. And who has done this reduction? H2S is converted to sulfur. Who has done the reduction? Reduction is done by SO2. So SO2 is acting as here the oxidizing agent. Similarly, they have not written the name of oxidizing agent. We can use anyone like a KMnO4, potassium dichromate, hydrogen peroxide. All these are possibilities are there. So this H2S is oxidized to water. So here oxidizing agent is providing us the oxygen and H2S is converted to H2O. Okay, so these are the two methods in the chemical. And further, now you see double decomposition is the same. Earlier also we discussed SO2H oxidation also we have discussed already. Now this method AuCl3 plus HCHO plus water. It is not mandatory that you have to use formaldehyde only, HCHO. We can use SnCl2 also. See here AuCl3 is same, SnCl2. Now you see SnCl2 is changing to SnCl4 and AuCl3 is changing to Au. What is happening? If you calculate the oxidation number of Au oxidation number is plus 3 and here oxidation number is Au is 0. Plus 3 changes to 0. Decrease in oxidation number. It means reduction is happening. And who is doing oxidation is, if it is 2 here, 4 here, here oxidation is happening. So this is known as reducing agent, this is known as oxidizing agent. So this way we know that this the method is oxidation method where plus 2, tin is having plus 2 oxidation state and here tin is having plus 4 oxidation state. Plus 2 oxidation state changes to plus 4. So who has done that? AuCl3. AuCl3 is oxidizing agent for that. Similarly, last method is hydrolysis. Earlier also we discussed FeCl3 plus 3 water give rise to FeOH thrice Sol plus 3 HCl. So this is the method of preparation of Sol by aggregation or condensation. Now other methods which comes under, previously we have discussed is chemical method, this is physical method. Physical method is excessive cooling. Excessive cooling means a colloidal solution of ice in a non-polar organic solvent can be obtained by freezing a mixture of water and solvent. So sometimes colloidal solution of ice in a non-polar solvent either can be obtained by freezing. If you are decreasing the temperature and the solution can be formed through this method, that method is known as excessive cooling. Next is exchange of solvent. Exchange of solvent, sulfur is soluble in alcohol but less soluble in water. But when the solution of sulfur with alcohol is poured into water, the colloidal solution of sulfur is formed. So this type is known as solvent. Earlier solvent was alcohol, now solvent has been changed to water. So this is known as exchange of solvent. One more is the ultrasonic vibration. Here also mostly that is very uncommon, but still I can tell you. So here we are passing the ultrasonic waves in that solution and that will be converted into the Sol. Means basically that it is used for oil and mercury type of solution, where mercury solution we have to make. Okay, so that's all for the method of preparation. And now we are going to discuss about the purification. Purification means removing the impurities. To what extent? To what extent it is possible. Okay, this we are going to reduce the impurities. We cannot say that 100% impurities will be removed, but to the possible extent we are trying to remove the impurities. What is meant by impurities? That is having the particle size is less than the colloidal size particle, that is called crystalloids. Crystalloids are the particles of true solution which is not retained in the parchment paper or filter paper, because it will pass through filter paper. Why it is passing through filter paper? Because the size, particle size is very less. It is very less than 1 nanometer. That's the reason. So now here purification by dialysis. Dialysis is what? Process of separating the impurities. Now you know that what is impurity. Impurities are crystalloids. What are crystalloids? Crystalloids can pass through the filter paper. Why it is passed through? Because size of the particles are very small or less than 1 nanometer. Okay, so these are also known as true solutions. So the impurities of true solutions are removed and impure solution by means of diffusion through suitable membrane such as parchment paper or cellophane. Now what will happen? For example, this container is there. This will be surrounded with the parchment paper or cellophane membrane. What will happen if these both particles are there? Let us say dispersed phase and dispersion medium, and one among the two is the impurity. Let us say the impurity will come out. What will come out? Crystalloids. Crystalloid will come out, and what will be remaining? The impurities would be not impurity. The impurity will be coming out like crystalloids, and the colloidal solution particles will be retained in the parchment paper or the vessels containing that covered with the parchment paper. Okay, so this way we are doing the dialysis. and it is used for purification of blood by artificial kidney. Okay, so next is electro-dialysis. If this dialysis is under electric field, we have applied electricity. What will happen? Because you know colloidal solution is having charge. So colloidal solution, the movement of the charged particle will be more or fast, or the passing of the crystalloids will be very fast. So in that way, what is going to happen is the process will be fast. So electro-dialysis is used to purify the blood also through artificial kidney. Next is ultrafiltration. So normally you know filtration is what? Filtration is you are taking filter paper and adding the solution, and some particles whose size are more, that will be retained. So basically this. Now what is special in ultrafilter paper? Ultrafilter paper is obtained when you take simple filter paper and we are doing the coating of gelatin on it. So why we are doing coating? We are doing coating to fill the pore size. Means some pores may be vacant, so that pores we are going to complete, or a specific pores will be remaining which allow the suitable size particle or undersized particles to pass through, but oversized particle will be retained. So this is the basic function of ultra filter paper. And how it is obtained? Ordinary filter paper, if you are doing the coating of gelatin and we are doing hardening with the formaldehyde solution, that will get the ultrafilter paper. Now what is the procedure in ultrafiltration here? Impure salt is poured over ultrafilter paper. Their impurity means same, crystalline. Crystalline means size of the particles are less than 1 nanometer, and this belongs to true solution. Particle pass through ultrafilter paper while the colloidal particles are retained on the ultrafilter paper. So it means to say that only those particles will be retained which is having size greater than 1 nanometer. Okay, so this is the basic difference of basic logic behind the ultrafiltration. In ultrafiltration, that collodial word is used. So collodial is nothing but it is a mixture of nitrocellulose in alcohol and ether. What is used for? It is used to prepare the ultrafilter paper. How we are preparing ultrafilter paper? You are taking filter paper, we are doing coating of our gelatin or of collodial. Okay, this way ultrafilter paper is obtained. Now the last topic here is ultracentrifugation. In ultracentrifugation, you know the basic centrifugation is what? We are having some solution and or some insoluble and soluble particles. When you put in the centrifuge, the particle will settle down under the influence of centrifugal force. Now the point is, in ultracentrifugation, we are varying the speed of centrifuge. How? Startingly we are keeping the low speed. For example, there might be number of particles. We want to separate that. What will happen? We are little bit decreasing the speed. So what will happen? So at low speed, what will happen? Few particles will settle down. So that particle can be removed and that another solution will be transferred to the next test tube. Then again same process, water will be added, and again then the centrifugation will be done, and then ultimately the next particle size will settle, and then slowly we can separate it out the different colloidal size particle of different range. It may be a multi-step process where water is to be added and at each step, and centrifugation has to be done at each step. Okay, and you know that what is the benefit? Because if you think of that gravity, it will settle, the particles will not settle, or only by the use of centrifugal force the particles will be settled fastly, and you can proceed for the purification of crystalloids. Purification of colloids, sorry, not crystalline. Next, so this is the all about the two procedures we have discussed already: methods of preparation of colloids and the purification. Dispersion and condensation methods are used to prepare colloidal source. Dispersion method, bigger size particles are brought down to colloidal size particle, that is of 1 nanometer to 1000 nanometer in the presence of dispersion medium. For example, colloidal mill, Bredig arc method, and peptization. So, and the third point is in condensation method, smaller particles of the dispersed phase are aggregated to form large particles of colloidal size. By which method? Chemical methods are there: oxidation, reduction, hydrolysis, and decomposition. Otherwise, exchange of solvent and excessive cooling is also one of the method to prepare to purify the colloidal source. So again, I would like to repeat the thought: loyalty and respect goes both way. If they don't return it, they don't deserve it. So thank you, students.